Picture this. A platform enters service with no obvious peer. Its threat model is clear. Its mission envelope is narrow but decisive. Everything about it is optimized for one condition: to dominate a known environment faster, cleaner, and more reliably than anything else in the air. Not to adapt, not to expand, but to win, immediately and conclusively, inside a clearly defined frame. For a while, that kind of design looks unbeatable. The system performs exactly as intended. Every major subsystem aligns. Nothing appears wasted. Nothing feels provisional. And that's precisely where the story becomes interesting. Because engineering systems don't fail when they fall short. They struggle when they reach an endpoint. The F-22 was not designed as a flexible foundation. It was designed as a solution to a specific problem set: air dominance against a peer threat within a stable geopolitical and technological window where the rules of engagement, detection, and escalation were largely understood. That context matters. When a system is built under those assumptions, its internal logic becomes extremely tight. Margins shrink, interfaces harden, trade-offs stop being negotiable. What you gain is peak performance, what you lose is room. This is where the common explanation usually goes wrong. The popular narrative says the F-22 stalled because it was too good, too capable, too far ahead. That framing treats performance like a resource that naturally carries forward, but performance doesn't compound, it concentrates, and once concentrated, it locks the system into a narrow path. In engineering terms, the F-22 reached a point of path completion, not because engineers stopped innovating, but because the system had already resolved its internal tensions. Stealth geometry, aerodynamics, propulsion, sensors, and flight control were all balanced around the same goal. Change one, and the rest no longer line up. Add more sensing, and power and cooling assumptions break. Alter the mission profile, and the airframe's optimization stops making sense. Expand the role set, and the tightly coupled software-hardware loop begins to strain. At that point, upgrading stops meaning iteration. It starts meaning redesign. This is the critical distinction. The F-22 was not hard to improve because it lacked capacity. It was hard to improve because it had already spent its flexibility. Every major decision had been pulled forward. Every compromise had already been resolved. What remained was a system that worked, but only within the boundaries it was born into. And those boundaries didn't disappear. They just stopped being stable. Over time, the environment changed in subtle but decisive ways. Not a single dramatic shift, no sudden failure. Instead, pressure accumulated. Missions began to emphasize persistence rather than brief dominance. Networks mattered more than individual platforms. Information flow outpaced kinematic advantage. Coordination stretched beyond what a single optimized node could easily absorb. None of these demands invalidated the F-22's strengths, but they didn't fit cleanly either. And that mismatch is where evolution gets expensive. At this stage, systems face a choice. They can remain exceptional within their original lane, or they can reopen decisions that were once considered final. The F-22 chose the former, by necessity, not by neglect, because reopening those decisions would have meant unraveling the very coherence that made it effective in the first place. That's not a political outcome, it's an architectural one. This is why the F-22 didn't gradually transform into something broader. Not because it lacked potential, but because its potential had already been fully expressed, under assumptions that no longer held steady. Once a system reaches that state, the question stops being, how do we add more? It becomes, is this still the right system to carry the future? And that's a much harder question than performance alone can answer. When people talk about the F-22's limits, the discussion often turns technical very quickly. Avionics constraints, software complexity, integration cost. Those explanations sound convincing, but they miss the deeper signal. Because difficulty is not the problem, difficulty is the symptom. In any large system, upgrades are never free. They work only when the system still contains unused margins, structural slack that can be reassigned without breaking alignment. That slack can take many forms: excess power, unclaimed bandwidth, uncommitted volume, loosely coupled interfaces, or simply design decisions that were intentionally left unresolved. The F-22 had very little of that left. By the time it entered service, most of its internal trade-offs were already settled. Not postponed, not deferred, settled. The airframe shape wasn't a placeholder. The propulsion layout wasn't provisional. The sensor fusion logic wasn't an early draft waiting for expansion. Each element existed because it fit tightly with everything else. This is what peak optimization looks like in practice, and peak optimization has a cost. When a system is optimized this tightly, any new requirement becomes invasive. Adding capability doesn't sit on top of the structure, it pushes into it. A new sensor isn't just a sensor, it demands power, cooling, processing, software validation, and integration into an already closed decision loop. A new mission role isn't just doctrine, it reshapes how the platform is expected to survive, persist, and coordinate. At that point, the question is no longer, can this be added? It's, which existing assumptions must be reopened to make room? And reopening assumptions is dangerous, because assumptions are load-bearing. They define why components were sized the way they were, why margins were trimmed instead of preserved, why interfaces were hardened instead of left flexible. Undo one, and the system's internal balance starts to drift. That's when upgrades stop behaving like extensions and start behaving like redesigns. This is where the idea of evolution quietly breaks down. Evolution requires continuity. It relies on the ability to change one layer without forcing every other layer to move at the same time. The F-22 did not have that separation. Its strength came from integration, but that same integration reduced modularity. The system didn't leave much behind that could be safely repurposed later. So when the environment began asking different questions about persistence, about distributed coordination, about long-duration relevance rather than momentary dominance, the F-22 wasn't incapable of responding. It was structurally resistant, not because of neglect, but because its architecture had already converged. This is why calling the F-22 hard to upgrade misses the point. Hard upgrades usually mean something deeper, that the system has already consumed the very flexibility upgrades depend on. At that stage, improvement doesn't scale linearly, it compounds cost, complexity, and risk. And eventually, it stops being rational to keep pushing in the same direction. None of this diminishes what the F-22 achieved, but it reframes what that achievement represents. Not an unfinished platform waiting to grow, but a finished answer to a question that stopped being stable. Once a system reaches full internal alignment, there are only two ways forward. Either the environment stays stable, or the system must be rebuilt. The F-22 assumed the first. Later systems were forced to plan for the second. What changed wasn't a single technology, it was the nature of the problem space. The demand shifted from winning a clearly bounded fight to remaining relevant across an open-ended one. That shift doesn't reward completeness, it rewards tolerance. Tolerance for change, tolerance for uncertainty, tolerance for missions that haven't been defined yet. And tolerance requires something the F-22 deliberately minimized: uncommitted capacity. This is the part that often sounds counterintuitive. Leaving things unresolved is not a failure of design, it's a strategic choice. Later systems began to accept that some performance would remain unused, that some interfaces would stay loose, that some decisions would be postponed, even if engineers knew how to optimize them immediately. Not because optimization wasn't possible, but because locking them in would narrow the future too early. In other words, the lesson wasn't, don't build something as capable as the F-22. The lesson was, don't spend all your options at once, because once options are gone, no amount of technical excellence can buy them back cheaply. This represents a different definition of success. Not peak dominance at entry, but survivability across shifting demands. Not maximum integration, but selective separation. Not finishing the answer, but keeping the question open. From that perspective, the F-22 becomes a reference point, not a template. It shows what happens when a system is allowed to complete itself fully inside a narrow but well-understood frame. The result is extraordinary effectiveness and long-term rigidity. Both are consequences of the same decision. Later designs didn't move away from the F-22 because it failed. They moved away because repeating its approach would recreate the same structural limit under faster changing conditions. And in a faster system, that limit arrives sooner. This is why the conversation about evolution can't be reduced to technology cycles. It's about timing. When optimization happens, matters just as much as how well it's done. The F-22 optimized early and thoroughly. The cost of that choice only became visible after the environment stopped holding still. By the time the limits of the F-22 became visible, nothing had gone wrong. The aircraft still worked. Its advantages hadn't disappeared. Its original purpose remained intact. What changed was everything around it. The system it was designed to dominate stopped being the system that mattered most. This is the part that's easy to misunderstand. The F-22 didn't lose relevance because it fell behind technologically. It lost flexibility because it had already arrived. Every major decision had been made early. Every trade-off had been resolved cleanly. Every margin had been intentionally consumed. That clarity produced an extraordinary result and a narrow future. In complex systems, there is a quiet difference between strength and endurance. Strength is what you get when all variables align at the same time. Endurance is what remains when alignment breaks. The F-22 was built for the first condition. It succeeded completely, but success in this case also meant closure. Once a system reaches that state, it can still operate at a very high level. What it can't do easily is change direction without starting over. Evolution becomes expensive, adaptation becomes disruptive, and continuity gives way to replacement. Not because the system failed, but because it left no room to bend. This is why the story of the F-22 is not a warning about chasing performance. It's a warning about when performance is locked in. Peak capability, achieved too early, can freeze a system in place. And when the environment keeps moving, that freeze matters more than raw power. So the real lesson isn't that the F-22 was too strong. It's that it was too complete for a world that stopped staying still.